Alright, so I'm going to go through the problems about gradient. I actually am going to spend some time on going over law of sines, the ambiguous case, one more time, just to visually show you how the ambiguous case even comes about. So in your law of sines notes, there was a second example which was related to the first that we didn't get to do in class, but I think it's an important example to just see how the three possibilities arise. So remember, if we use law of sines, and the first thing we use law of sines to find is an angle, you potentially could have two triangles exist. We actually could end up having no triangles exist. That one's pretty obvious because you're going to try to find the sine of an angle and the value they give you is going to be bigger than 1. The other way that we identified it, we made the foundational connection to when you guys took geometry, and that hopefully your teachers made the little joke, you can't curse in geometry, and that's why ASS is not good and not used for congruent triangles. So to start off, I'm just going to draw a figure of a triangle, A, B, C. This is side A, which they're telling us is the side that we don't know. This is 30 degrees, and side B is 50. So this is related to the example we did in class, but what I want to start out with is this height of the triangle. The definition of a height is the fact that that is perpendicular to the opposite side. It's also the shortest distance that you can get to the opposite side. So I'm going to call this side H, and I'm going to use SOHCAHTOA, because it's a right triangle, to find H. So that would be sine. So sine of 30 is equal to opposite over hypotenuse. And the right triangle I was using was this side. Okay. So given that I have that, what this tells me is if my height is 50 sine of 30, well, then that also tells me that if my A happens to be 50 sine of 30 exactly, then I know that there would only be one possible triangle. And this is how we get one triangle. That one triangle happens to be the right triangle. There's no other possibility for A. And this is how it would happen. Now, if A is too short, so let's see, let's draw the triangle again. If we know that this has to be 50, and we know this is 30, but we don't know how long this piece is, this is consistent, has to be that long. The third side here, side C, is also not given. So the only way no triangle could possibly exist is if your A is just too short and it doesn't ever even connect to side A, B. So if this little A is too short, then you actually have no triangle. So visually speaking, that's what happens. So remember that the height is equal to 50 sine of 30 degrees. So if your A is too short, it means it's shorter than the height. So that's how we could potentially have no triangle. I forgot my A. Okay? And then the third option of having two triangles, it will be because given the same triangle, actually let me not put in that third side, I mean the second side. So, same thing, 50. We don't know how long this side is because it's optional. They did not give it to us. They didn't set that side. So, the only way that you could have two triangles is given the height of this triangle that we found, Lord, in the first triangle, that height, if our A happens to be bigger than it. because if we're bigger than that height, and let me actually fix this so it looks a little bit nicer. Okay, so that's supposed to be the height to this third side, however long it might be, but if my A ends up being bigger than that, it'll swing. What I mean by swing is the A, if it's bigger, that would be there, or it could even be here. So that'll show you that the possibility of two triangles exists. There's one of them, triangle 1, that's 30, and that's 50. Or there's triangle 2, where that's still 50, but now it's over on this side, and this is still 30, and this is still 50. So this happens when your A is now bigger than the height. So some books actually make you memorize when there's going to be two triangles, or to check for two triangles prior to doing the problem. And if you kind of remember this example, it should make sense. Visually speaking, if your side, that side A happens to be bigger than the height, you get two triangles. If it's exactly the same as the height of the triangle, then it's one triangle. And then if it's less than the height, then the triangle is just not even possible. All right? So I did want to go through that. Law of cosines, again, the only reminder is if you are calculating the angle, please make sure that these steps right here are taken where you move these terms first out of the way. That's these two terms, moving it to the other side, and then you have a coefficient in front of cosine of r. This piece right here is the coefficient of cosine of r, so it can't be combined with the 5 squared and 4 squared. I'll even take the negative with it. All right, applications. To start off lines and angles, I just want to review a few equations of lines that you probably know. Y equals mx plus b. That's your most famous one, the one you use in calculus. Y minus y1 is equal to m times x minus x1. That's called the point slope form because you need a point and you need a slope to write that equation. This here is known as standard form. And then for some reason IB enjoys using this form of standard instead, setting it equal to 0. They're both exactly the same. If the c value is 2 in this form, then the c value becomes negative 2 in this form. You do have to be able to interchange between all the forms. If I give you, and when I say interchange, usually the only reason you would want to interchange is because they give you the form in a way that may not be as helpful. So what I mean by that, notice this form, slope does not show, no slope. So you might want to rewrite the form into y equals mx plus b so that you can actually identify the slope. All right, the other vocab word you'll see is actually gradient. That's the European fancy way of saying slope. So when you see the word gradient, it just means slope. So going through, I'm just going to go through the first example. I want the video to be short, so I'll see if I go through the second one. So find the acute angle between the lines. Oh, well, that's a little bit too advanced. Let's back up a little bit, and I don't know if I gave you space for this. Well, we actually can use this. So given that I give you any two lines, to find the angle between, you actually just need to find the angle of each of the lines first, and then after that, you can actually find the angle between because we would do a subtraction. So I'm going to highlight in the picture real quick that what's needed is the fact that that's your horizontal, and I'm going to take one of the lines, this line here, and I'm just going to redraw that figure, not as nicely, obviously. Okay, and this one was y equals 5x minus 2. So this is the horizontal. I'm ignoring the other line. which was the 1/3 x minus 1 for now. And what they're asking you to find is the angle between right here. So the question is actually the angle between the two lines. You're going to need to find the angle between the horizontal and each line to be able to do the question. And this is related to slope. So what creates the angle is how much the slope is, because the slope determines the steepness of a line. So if you think about slope, it's actually a ratio. So the slope of the sine is 5. So if I create any right triangle, then the ratio between the kind of like slope would be fine. This would be the delta x, this would be the delta y. Wow, I said it backwards. Delta y, and this would be the delta x. So the ratio between the y over x of this right triangle has to equal the slope. So because it's a ratio, I can identify this side, and I can make this 5/1, so rise over run. So the slope being 5/1, I can use any ratio that is equivalent. So if I really wanted to, I could do 2.5 over a half, or 10/2. So the easiest thing is to use 5/1, and to find the angle, I would use a right triangle that's opposite. This one's adjacent. So the tangent of the angle, see, is equal to opposite over adjacent. So what you start to notice is that the tangent of the angle is actually always equal to the slope, because we're going to always use that ratio. So to find the angle, you use your calculator and you do tangent inverse of 5. And I'm going to see if I have a calculator available to use. So I don't have a calculator set up on my computer, so here would have been the first angle, and we're just going to do the same thing with the second angle, which was, let's see, oh, you know what I just realized? My horizontal line moved, so let me erase that. So again, I'm going to take in green this guy versus the horizontal. Okay, so that horizontal and that line, so here's the horizontal, here's the angle, so the theta would be here. I'm going to create the right triangle. The ratio is opposite over adjacent for the right triangle, also because the slope for this line happens to be 1/3, so that's the rise and that's the run. Alright, so given that I have my right triangle set up again, I have that the tangent of the angle has to be opposite over adjacent. Remember, we already know that the tangent of angle is the same as the slope. And so angle 2 would be the tangent inverse of 1/3. And then the difference, or the angle between, would be a bigger angle minus the smaller angle. So I want to angle distance, it's going to be a positive number. So some books actually even show the equation of a line, y equals mx plus b, differently. They'll show it as y equals m being the tangent of the angle times x, and then plus b, because that definition actually is the same. So we're using the definition that the tangent of the angle is the slope. So that's the angle between. You're welcome to turn off the video at this point. I am going to continue and just talk about some of those example problems we didn't get to do in class for 7.5. There's this one here that you could easily do, hopefully based off of what you know. Remember that slope is equal to the tangent of the angle. All these examples I did take from the book, knowing that we might not have enough time to go through each one. So the answers are in the textbook with explanations, so you can also go through those. This problem, you actually got in honors geometry, and then you got the same type of problem in honors pre-cal, and it is the boat that moves, and now you want to see, I guess they ask you a question in this case. So in this case, they want to know the height of the, what is that thing? The lighthouse? Couldn't think. given that we know that, let's use orange, that this is 40 degrees from this line. That line happens to be parallel to the ground or the water. And so using alternate interior angles to this line, then I know that this has to also be 40 degrees. And for the same exact reason, I know this has to be 25 degrees. I know that there are two right triangles. And this is usually how we set up this type of problem. Because right triangles are really nice. Right triangles mean I can use SOHCAHTOA. I know that this is going to have h right here, but this whole side would be h plus 470. I know that this piece, I'm going to have to call this x from here to here because I don't have anything labeled there. This would be 500 plus x. So I have two unknowns in this figure. I'm going to draw the other triangle in purple, which is a little bit of a steeper line. This is 40. This is still h plus 470. And this side is now x. So to set up this problem, because they're right triangles, and if you notice, we're doing everything based off of the opposite side and the adjacent side, then I will use tangent of 25 is equal to opposite over adjacent. This one is tangent of 40 is equal to opposite over adjacent, and it's a system of equations which has many different ways you can solve. In this case, what I notice is this piece right here is equivalent, and because they're equivalent, I can actually solve for that in both of them. And then I'll show you that the one way would be over here. We could do 500 plus x times tangent of 25 equals height plus 470. And then you can actually substitute that right in, or you can solve this equation also for height plus 470, and then you can set them equal to each other. It doesn't matter which one you do. In the end, you will end up solving for, in this case, x, and then you'll use one of the ratios in red that have the green highlight to find h. So that's the setup for example 3. Example 4, diagram here. I wanted to point out that this question is starting to use compass bearings, and just to mention that a compass bearing, it's nice because they gave you the diagram, a compass bearing always starts from the north and goes around in this direction, which is not the way that we usually do our angles. So our compass bearing here, and I actually don't like the way the diagram's given. I like always seeing a compass corner is what I call them, but pretty much the quadrants at each of the angles. To me it helps. But the figure's already given, so you would use all the information. So at this point, I want you to make sure you remember, because this is the application section, that you know SOHCAHTOA, you know law of sines, and you know law of cosines. So you want to look for triangles. SOHCAHTOA is if you have a right triangle, so you need a 90-degree angle. Law of sines, you need one given ratio or pair of opposites. That says ratio and third piece. And then law of cosines works for SSS, which means you'll end up finding an angle, or it worked for SAS, where you'll end up finding the third side. Okay? So, nice little application problem. These I wanted to mention because I have seen on old external exams a lot of these 3D problems, and 3D problems are a little bit harder just because visually you do have to be able to see what's going on. So I'm actually going to highlight for you the fact that this piece back here is the back wall. So if you don't understand that, it sure makes the problem hard to visualize, and then you start not understanding how there's like two right angles over there. So that's really the major thing I wanted to mention. The triangle is popping out towards you. So you want to understand that they are telling you that there's two right triangles, meaning this, and I'll highlight as well as I can, this triangle here is a right triangle, and then, sorry, oopsie, I have a tendency to move the image. Oh Lord, I moved it again. Okay, so, and then this triangle, which is like the left wall of the triangle, oddly enough, also a right triangle. Okay? And third one here is a rectangular box. It says find the measure of angle ABC, which is this angle between diagonal 1, let's call it, and diagonal 2. And these diagonals are pretty easy to find because the triangles that create the diagonal are right triangles. That's actually a right triangle. And the area of the triangle, once you find that angle between, you will be able to find the area of the triangle, because we're not going to use the formula that you're used to. We're going to use the area as 1/2 AB sine of C. Okay? And sine of C, the angle between, that's the angle ABC. Okay? So it's just some hints, because I wanted you guys to work in groups to kind of go through these problems and to discuss them, but we obviously did run out of time. All right? So if you do need help on these problems, the solutions are in the textbook, but if you want to come in during lunch, I can sit through any of the questions that you need help on. Okay? All right. Have a fun weekend.